So good morning, good afternoon, everybody. Welcome to the latest of our Enterprise 5G private networking webinars. This one's a little different. You may notice the formatting of the videos. Dustin looks great there with his Nokia background. But I'm down here in Austin, Texas, and as you may have realized on the news, things are a little crazy down here. So the power here keeps flipping in and out. So I'm working this on my laptop, connected to my phone for a hotspot. Matt from IGR, he's up in Chicago, and he's actually going to run the slides for us. So if I drop, the whole session won't die. And then Oza, you can see there, he's in California. He's actually in his car. You can see his sunroof behind him. So between us, we've kind of cobbled this one together, but it's a good subject. We'll be talking about healthcare today. A little bit of housekeeping before we get started. Firstly, we are recording this session today. We'll send you an email afterward with details on how to download the video and access the video. We'll also make the slides available. We will be taking questions today, and we'll work in the questions as we go through. Just use the questions tab on the GoToWebinar control panel, and then we'll either take them at the end or we will we'll deal them as we go. Okay. In terms of the agenda today, if we go to the next slide, then firstly, I'm going to give, I should do this first, of course. Speakers, Dustin from Nokia, he's the professional looking guy with the jacket on and the blue background. I won't tell you how much software he had to install this morning to get that blue background. And then Oza, who is VP of Marketing for Celona. And obviously in his photo, he had a shave and he looks like a completely different guy, but it is him, trust me.
8 years ago. Yeah.
Right. And then the final thing I should say is that these webinars as well are being supported by the OnGo Alliance. Obviously a lot of companies, members there as well. And we'll get talking about CBRS later today as well. So go to the next slide. And then we'll talk about the agenda. Firstly, I'm going to ask Oza and then Dustin to introduce Celona and Nokia. Then we're going to get into what are the the use cases, the private network needs for healthcare. Healthcare is pretty specialized. It does, you see specialized companies like GE and Siemens in there. You can't just walk into a hospital usually and install a network. It's a lot more sensitive than that, obviously for intensive care and things like this. So we'll talk about that. We'll talk about the communication needs. We will talk about the critical success factors and then really lessons learned. So how do you avoid these problems? And then wrap it up and the questions. So we do have some resources here as well. The slides I've just noticed that we'll send out. There's actually some updated links on there for Celona there, so I'll send that to you afterwards. So we go to the next slide. So this is the slide I've shown before. It's kind of the so the world what it looks like in a few years' time, and where everything is 5G. 5G to us is not just one spectrum band. It's not just millimeter wave. Some people talk about the 5G band. We also don't see 5G as just being on a macro tower, but also in a small cell and indoors as well eventually. So just as LTE is pervasive today, so 5G will be the same way. Obviously, today we're going to talk about healthcare, which if you look at the top and bottom of the slide there, you'll see the hospital with an ambulance, and then down the bottom you see another ambulance, emergency services. So private networking here can be obviously in the hospital. It can also be outpatient in the doctor's office, but also in the ambulance as well. I think Dustin's going to touch on this later on. So you get in some pretty sophisticated networks here. There's obviously a lot of different use cases, a lot of different applications, from voice to patient records. The one we probably won't talk about is the one that gets hyped a lot, is remote surgery, robot surgery. Usually when people talk about 5G, they come to that. Not saying there's not a use case there, I'm just saying that there's a lot more stuff beside that as well, okay? And I will tell you that during COVID, you know, I've had a couple of appointments with my doctor actually for COVID testing, and they always start now with telehealth, and it is fantastic. It's great. So that I'm one who hopes that doesn't go back in the that genie doesn't go back in the bottle. So we go to the next slide. A couple of stats for you. Then I'm going to hand over to Oza for to introduce Salona. So from the US healthcare perspective, how big is it? How is it growing? And I've got a couple of charts here, some stats. So if you look on the left-hand side, this is actually from our vertical industry forecast work we do. The numbers are based on the CBEX data from the government, and then we apply a forecast to that. But if you look on the left-hand side, you can see that blue is the inpatient buildings, red is outpatient. There's actually about 9,000 or so hospitals in the US in 2020. It grows up to about 11,000 by 2025. Doesn't sound huge, but we'll talk about square footage in a minute. If you think about a hospital, they're typically pretty big. The red line is outpatient, so this could be a clinic, urgent care, doctor's office, etc. And on this one, you can see actually it goes from about 135,000 buildings up to close to 160,000. So what's that, about 30% or so growth, which is obviously pretty good. So and if you think about what's happening in the world and what everybody's trying to do, but also a higher population, as populations grow, suburbs grow, you get more urgent care, etc., etc. If you look on the right-hand side, this is the square footage for those buildings. And you'll see the red on the bottom, of course, is a smaller group. The blue line is pretty big. That's 2.3 billion square feet of hospital space. Now, the average hospital inpatient is about 250,000 square feet. An important note here, in Austin, for example, we have the Seton Hospital downtown. It's actually 4 or 5 different buildings. That would count as 4 or 5 different buildings on the left-hand side, and each building would be roughly 250,000 square feet. That whole thing, that whole complex is over 1 million square feet. And that's not untypical for a hospital. If you think about your local hospital, it's probably set up like that. So the average there's a little misleading, but the outpatient average is about 190,000 square feet, which again, if I think of my doctor's office, that's a little bit smaller, but some other places obviously could be a little bit bigger. But good sizes, ideal for private networks. We'll talk today about security and all those things, and the need for coverage, etc. But that's how the world, that's how it all kind of fits together. So with that, I'm going to hand over to Oza, who's got a couple of slides here to introduce Salona. So Salona, Oza, who are you guys and what do you do?
Absolutely. Thanks, Ian, for the introduction. Hello, everybody. In case we have not met before in the enterprise networking circles or previous webinars, very nice meeting you all. Thanks for spending time with us here. Just to tell you about my environment right now, I'm hooked up to my AirPods Pros on Bluetooth to my laptop, which is using a Wi-Fi hotspot, and on my phone, which is connected to an AT&T wireless network. So as you can tell, I love wireless and I love cutting cables. And one thing that you should probably remember about Salona is there's tons of people in the company who loves cutting cables. My background goes to 10+ years at Aruba Networks. Some of you might be familiar with, along with our CEO and co-founder Rajiv. So he brings a lot of enterprise networking DNA to a highly talented group of engineering teams, led by Mehmet Yavuz and Suparna Kumar. They have Qualcomm and Jasper wireless background. So lots of understanding of the cellular wireless ecosystem and relationship with service providers as well as enterprises. We like to call ourselves the cloud networking folks when it comes to private 5G. So, you know, you have cloud networking solutions for Wi-Fi, switching, SD-WAN. But that level of simplicity and automation and ease of use that we set up for enterprises on those specific connectivity technologies did not exist so far with private 5G. So That's what we're trying to do, bridge the gap between enterprise networks and cellular wireless. We've been around for the last 2 years. We're backed by tier one VCs in the Valley like Norwest and Lightspeed, in addition to strategic investors, Servin, Qualcomm, and NTT Venture Capital. We've been recognized by a variety of different organizations as a cool, innovative leader in the space. But most importantly, we have started getting quite a bit of acceptance from enterprise customers as well. So I would love to tell you more about how and why. So Matt, if we can go to the next slide. I think the executive summary is as follows. We believe that enterprises today, if they want to get access to private 5G, they're really looking for something that they can deploy themselves if given the chance. They might always prefer to go with a managed service provider or system integrator and work closely with them. But there seems to be quite a bit of organizations out there that want to just one kit solution, integrated, easy to deploy, easy to manage, and scale very simply, similar to how they deploy enterprise switching and Wi-Fi. We have been lucky enough to sign our names next to some cool innovation, microslicing. I will touch upon a little bit more, but brings in those 5G standard capabilities, cloud native software DNA, being able to make the wireless network application and device aware, and those capabilities have really differentiated us in the market and allowed us to reach out to key enterprises in our customer base today. We deploy within an existing enterprise network. This is not a separate fiber pole. Your data doesn't leave your premises to go to a service provider network. It's just private to you. It's used in your environment, within your infrastructure, which makes it, of course, very easy for enterprise to wrap their head around what we actually do. The cost base is very much similar to enterprise Wi-Fi switching model. So if you're an enterprise IT professional, OT professional spending X amount of dollars on connectivity needs today, this is not going to stick out as a very different pricing model or a very different cost metrics. And since this is your private network, you're not paying on a metered basis, right? So this is not a per client, per user, per SIM card type of payment model. This is, you buy the infrastructure, you subscribe to the cloud management service, and you're up and running. So it's very much in alignment with your purchasing patterns that you have today as an enterprise. So unwrapping the onion a little bit more in the next slide, just wanted to give you a picture of the summary of the conversations that we're having. I think this is more of us learning from the market and translating in these two slides rather than trying to talk more about what Celona does. I will dive into that a little bit more in the rest of the presentation. But what are we learning from the market? What we're learning is healthcare professionals, operations teams, IT organizations across different enterprises, not only healthcare, they're looking at these three technologies as complementary. I think it's, we see a lot of messaging out there that might be, hey, 5G is going to eat Wi-Fi's lunch and it's going to replace it all, and we no longer need cables and everything's going to run on wireless. So that's a little bit, there's a little bit out there at the edge, right? So we think that LTE 5G, given the different technology capabilities that they offer, they're really designed for real-time compute. The stuff that needs low latency, guaranteed throughput, clean spectrum, stuff that cannot fail, right? In a hospital environment, this could be voice communications for nurses, video surveillance or computer vision for physical safety and security, and a variety of use cases I'm going to mention down the road. So we think that all of these have a place in the enterprise network, and our architecture is trying to make it really gel well together, right? If all of these technologies are used at the edge of the enterprise. So in the next slide, I tried to, again, summarize some of these, conversations we had with the healthcare professionals and the IT teams that they support. They care about really three things. Information technology teams are usually trying not to be as reactive to network problems, right? They're trying to make sure the network never goes down. So they wake up on a Monday morning, what they really think about is, hey, Do I have any network problems? Do I have uptime problems? Can private 5G practically improve my service levels and uptime? You know, I'm at 98% uptime right now. Can I make that 98.5, right? How can private 5G help me? They're very practical in the way they look at this technology. Operational technology teams, they're more come from a compute mind frame, right? Hey, I used to run applications on stack of servers, can actually start using edge compute that is connected to the cloud services from Azure, AWS, and maybe roll out digital apps, digital initiatives much faster? Can I improve the security, privacy around my applications and my data much more easily? Can I, move the business forward by digitizing manual processes? So they're more on the app side, they're more on the compute side. But ultimately, since the nature of the healthcare business, everybody's running around trying to serve the patients. That's the ultimate goal. They usually create lots of problems for wireless networking people in that hospital, saying, hey, I have 10 more apps to put on the network next Monday. Are we ready? Right. So, and then we identify a third audience, which is what we call the innovation teams, right? These folks don't necessarily have weekly targets or uptime targets or compute budgets that they need to spend with a cloud provider. They're thinking a little bit long term. They look at private 5G and say, well, we might have missed the boat on SD-WAN. We didn't miss at the right time. We might have missed the boat on Wi-Fi. We don't want to do that again. Let's focus on a variety of different technologies that will define the next 5 to 10 years. And what we're seeing is private 5G. If it's not on the top of the list, it's definitely within top 3, right? So if you're not thinking about a private 5G strategy today, a variety of organizations that we talk to, they feel like, okay, we might be running late here, so let's get in the game. So these are some of my observations from the market after a quick introduction to Celona, but I will yield the floor for the next section until I pick up back again with use cases.
Okay, great. Thanks, Jose. So, Dustin, I think most people know of Nokia. They probably know you for either the phones or network equipment, but you're actually in the enterprise group, and obviously you do quite a bit in healthcare as well. So, and of course you have your standard slides with lots of cool photos. So
and few words, right?
Yeah.
Yeah. So yes, I think if you're older than 30 years old, you undoubtedly know Nokia. You probably know us from the 1990s cell phones. Back when they were shaped like candy bars, they had buttons, and they had unbreakable screens. It's a different world we live in today. But our history actually goes back a long ways before that. We were founded in 1865. Paper mill, paper pulp, moving to rubber boots, and then cell phones. So I'll let you guys draw your own line of trajectory on that product background. But when we had the cell phones, our logo was actually connecting people, and my background did have that earlier today, and I took it off because it's legacy. We're actually connecting more than people today. We're connecting intelligence, we're connecting machines as part of the industry 4.0. Can you go to the next slide, please, Matt? So just at a glance, some numbers here to give a sense of scale. So our sales last year, 26 billion. That's my own math, converting euros to dollars, so it may be slightly off. It's important to know because we're spending about $7 billion a year on average over the last 2 decades in R&D. And to be a tier 1 provider, that's what it takes. It takes a lot of R&D investment, and that includes things like 5G, which of course we're a leader. We have about, I think it's 1,300 patent families as the #1 holder of patents for 5G. So we are on that bleeding edge of technology. And of course, looking at taking that and converting that to the enterprise. We were the world's first 5G standalone private wireless network. I think that was in July. My footnote helps me there. We're also #1 in private wireless networks. Our Q4 annual report, we announced that we had more than 260 networks deployed, and that's deployed globally across multiple industries as well. Can you go to the next slide, please? This one's a little bit fun. Catches a lot of people by surprise, even inside of Nokia. I have to say that we have Oscars and Grammys and Emmys and Nobel Prizes. Our Oscar, in fairness, was from the 1930s, talking about sound recording, which makes sense. That was probably important for movies in the 1930s. But moving to the left, we start getting some more important things. So if you look at Emmys, our 3 Emmys are around fiber optics, digital cameras, and even high definition cameras, or high definition TV rather. And then the Nobel Prizes are interesting in their own right. Our latest one from 2018, I believe, was actually medical related. And it was talking about, or it was all to do with optical tweezers in biological settings. So being able to do things like suspend viruses, stuff like that. So some pretty interesting background. And this, of course, is coming from Bell Labs, which Nokia acquired Alcatel-Lucent back in 2015. And now we are the custodians. I like to say we're the custodians. I don't think we're really the owners of Bell Labs. We're more the custodians and carrying the torch there. But a lot of really interesting innovation comes out of Nokia and out of Bell Labs. Things like Unix and C++ and transistors and solar cells, things that we typically use every day. So a pretty rich history in technology in general, and more specific, a huge amount of investment to be a global leader in 5G and private wireless. All right, next slide.
So maybe I can pick this up from here. We're kind of doing a little bit of handovers here, but just to continue the talk track, on our end, putting those customer priorities in mind, we said, hey, look, let's try to create that package. And when we started our journey, we realized that enterprise did not necessarily speak cellular wireless lingo. They did not read any 3GPP standards. They did not exactly know what P gateway, S gateway was in an LTE evolved packet core. They didn't know what an evolved packet core is. And along the way, what we realized is, okay, we don't have to necessarily teach them for them to actually use a technology, as long as we use their language. So we build a system. It's an all-inclusive package, comes with a platform with an on-premises or cloud-hosted mobile core where the wireless traffic terminates from the access points that we provide to our customers. Each access point comes with a certain number of SIM cards, all baked in to a single package, single subscription. And a lot of it is powered by that unique technology called microslicing. I think the key value that we provide here, if you are familiar with using an enterprise networking product, you should be able to bring this up. Running a demo should take 30 minutes, if not less. Running a pilot network should take an afternoon. And you should be able to get going, testing the technology, testing the efficacy of LTE 5G against your devices, against your applications very quickly. Ultimately, that's the big goal. We're trying to carve out a good portion of our infrastructure, device infrastructure and app infrastructure to support those use cases. So the quicker we get to that goal, the better. And a little bit more about the technology in the next slide. What we have done is virtually looking at it, right? So that's kind of the box view, if you will. What's running inside the boxes is this unique technology called microslicing. It essentially it gets inspired from 5G network slicing concept / the way it's written in the standard, and says, how can we slice the network, the wireless network, with specific SLA metrics, throughput, latency, packet error rate, for specific device groups and specific applications. Wi-Fi has been great in the enterprise. I worked on it for 10 plus years, but we never were able to guarantee a clean spectrum, no interference. We never were able to guarantee specific latency metrics for a very targeted application or a device. And we were never able to guarantee seamless roaming. Every device roams exactly the same with no hiccups. Never able to guarantee that. Not saying bad things about Wi-Fi, it's just what it is. So when you're running mission critical stuff that shouldn't go down, it's running on a wireless network, you want wire-like performance, you want to be able to run them on all the radios that you have deployed. And as these devices roam around, each radio in your network, in your facility, will support different traffic types and application flows. So somebody needs to manage that chaos. Somebody needs to say, this video stream, this voice stream, this IoT stream is actually running at the quality that we want. So that's where our software comes in. That's where our microslicing comes in. And in the next slide, I think I give you a picture of the network diagram. So again, you're an enterprise IT, OT team. You have application infrastructure you're working with, your LAN and WAN infrastructure you're working with. You might already have a Wi-Fi system in place. You're using some computer on wheels, maybe in the hospital. Patient guest access is running on Wi-Fi. They're bringing smartphones and tablets, maybe using some barcode scanners to scan, wristbands, and they're running on Wi-Fi. That's fantastic. So this is your existing hospital IT system in your specific geolocation. What do we do if we do one more click, Matt? Our Celona network design will stay on top. So it's very similar. You use your existing LAN and WAN infrastructure, quality of service policies, network security policies within that hospital network. Now you have devices with Celona SIM. Maybe it's Motorola Push-to-Talk, their latest handsets. Maybe it's robots that do delivery between rooms that they need reliable connectivity. Maybe those are the ruggedized tablets and maybe smartphones that you spend tons of money on and you give it to your nurses for use only within the hospital facility. The stuff that really should not go down. So those are the heroes of the story, and we take care of the rest, right? We integrate with their existing infrastructure. Traffic flows are very similar to a Wi-Fi system, and management orchestration of this entire infrastructure is also managed by us. So it's kind of a little bit of unwrapping the onion here again on the product side, on the solution side, how it looks, what does the package look like, and how it integrates with your network. Back to you.
Great. So before we go to Dustin, and Dustin's going to talk about some of the latency issues and bandwidth and applications and the networks and some of those issues for healthcare. We did have a couple of questions. If you do have any questions, just use the questions tab on the GoToWebinar control panel. So I have to look at my other screen here. So the question for you, Oza, is you've shown APs here. You're showing Wi-Fi APs and also Celona APs. So first question, is that your own hardware? And secondly, are you doing Wi-Fi APs as well, or is that off the shelf from somebody else?
Yeah, so we are assuming that the Wi-Fi infrastructure is there from somebody else, from like Cisco or Aruba. And our APs, our own hardware, our own software running on it. So we take care of RF management, micro-slicing capability I just talked about, ease of installation, cloud-based management of those APs ourselves. So it's a package system from SIM cards to AP radio hardware, indoor and outdoor, to the mobile core with Celona Edge and Celona Orchestrator cloud management.
Okay, and is that an LTE AP, or is it what technology are you running on there?
Yeah, very good question. Today they're running on CBRS band 48 for enterprise use and LTE wireless. Down the road we will have CBRS capable 5G radios as well, and then hopefully we will have international variations of our radios as well.
Okay, great. All right, so Dustin, over to you. You're going to get a little bit more into the architecture here and performance, and I know this slide here obviously talking about trends and pressures here from a healthcare perspective. So take it away.
Yeah, thank you. So maybe to tee up this slide with the conclusion, and the conclusion is we need something better for wireless communication. And so this is more or less looking at global trends and some unique pressures we're seeing in healthcare, but also some that cross across segments. And so it really starts with Industry 4.0. If you haven't heard that, you're probably living in a snow cave with an AM radio, but it's certainly something that's been big and growing with momentum over the last few years, and we see it across industries. And it's called the fourth industry revolution, the first one being steam, the second one being technology, the third one being digital, which we were lucky enough to live through essentially in 2000. So steam being in 1800, technology being 1900, digital being 2000, and here we are already with another industrial revolution. So what is that really about? It's about interconnectivity. It's about being able to analyze and understand the data. It's about being able to optimize, and it's also about being able to predict. And those are generic terms that, of course, realize great benefits across industries. So as a general, I've got 85% reduction in OPEX. I'm sure that was cherry picked from some slides somewhere. But the reality is, to be competitive in the landscape today, in whatever industry you are, you have to become more efficient. And to be more efficient, you need to adopt some of this new technology that allows you to do that. And some of that is things like IoT and automation, going to my next column there. And what we're seeing from the adoption of the technology and the interconnectivity of devices is it's driving a huge amount of strain on today's networks being Wi-Fi, which we've talked quite a bit about, the macro cellular or the public LTE networks, as well as the fixed networks. But when we look at wireless specifically, we at Nokia see, and this is coming from Bell Labs Consulting, about an 18-fold increase in capacity between now and 2025, which is just incredible. But beyond just capacity, performance, reliability, and high performance of the network, things like latency, predictability is very important. I'm going to dig into that on the next slide, so I'll park that for now. The next one, the number of devices we see connecting to these networks is exploding as well, because it's no longer just cell phones connected to it. It's machines and sensors and everything else. I thought that was actually a typo on the slide. The first time I looked at the slide, I hadn't seen the ZB too often, but 163 zettabyte, if I got that correct, by 2025. It's just mind-boggling. And then, of course, we have some influences that maybe we don't necessarily want, coming from geopolitical instability, COVID-19 in 2020. It's changing the way we do business, particularly, and I think you said at the beginning, you really enjoy this telehealth. You hope it stays around. Genie does not go back in the bottle. I don't think it will, because I don't think you're alone in that feeling. So the way we see the healthcare organizations look at their revenue chain management changes as a result of things like telemedicine, telehealth. So there's a lot of dynamic changing, but the underlying result of that is we need something better to offer as the connectivity layer, in addition to the things like analytics that need to take place at the edge these days. All right, so go to the next slide, please. All right, so this is a bit of a busy slide. I try to condense it as much as I could, but I think these are important topics. In my graph in the top right, this actually is hot off the presses. We did a study with Bell Labs and Aalborg University in Germany. It was a long study. It was actually focused on autonomy in warehouses, I believe was the actual setting, but it still holds true. The data still holds true. So what we're doing is we're looking at the delta between a public network, meaning your macro cellular, private LTE network, and Wi-Fi. We used a blend of Wi-Fi 5 and Wi-Fi 6 for the study. I have the more granular detail if anyone's interested. And then we looked at the network from a loading point of view. And so if you look at the axes, we're looking at predictability of latency, which is incredibly important for some of the use cases we're putting out there. If you don't need predictability of latency, you don't need security, you don't need mobility, use Wi-Fi. It's probably going to be a bit cheaper. It's probably going to be a bit easier, although I think Ozer mentioned that there is some price parity there, and I would agree with that as well. We're seeing that. But for applications that require better latency, better predictability, security, mobility, etc., that's where we see the uptake of what we generically call private wireless, so 4G and 5G, LTE and 5G. So the important takeaway on the slide is talking about loading. If you look at the dotted lines, those are loaded lines. If you look at the solid lines, those are unloaded single user. And so what we're saying is, hey, Wi-Fi actually performs really well as long as you have one user on that access point. It performs really well. But as soon as you start loading it, it really skews off to the left, as you see with the dotted line. So we're talking about 4 nines of availability at a ping time. Well, it really skews off quickly. It's off my chart. I can't tell you what that is. But at 1.2 seconds, it's there in text at 4 nines, which is not going to support many use cases that are going to be required for Industry 4.0 and digitalization of the industry. If you look at LTE, it skews up to 100 milliseconds, which in many use cases, that's fine. Of course, if you need to go lower than that, you could implement 5G, as my matrix there, or my diagram on the left shows, getting down to a single millisecond. But the takeaway here is, as you load your network, and you will load your network, and you add more devices and you add more data streams to it, that's where the wheels fall off Wi-Fi. I did beat up a little bit on the public network here, and I got to make for sure I call that in. This is using an external cell site. Nokia has recently signed agreements with both AT&T and Verizon, where, for example, AT&T has agreed to resell our private wireless network. That would be something very useful for something like a hospital setting, to be able to take that blue line and shift it all the way to the left and get that same performance as a private LTE network. So we have a great connectivity layer. It has great attributes to support the use cases. What are those use cases? I could probably go on for about an hour talking about different use cases, but I want to pull out a couple that are probably more relevant, and some that may not be so obvious. We talk about healthcare and private LTE. One of the use cases I see that transcends segments is security and access control. So think about high definition cameras. Let's say you want to add an additional set of high definition cameras. You have the choice to go out and run structured cable, or you could actually connect those using something like private LTE, and that way you're not saturating your Wi-Fi network. So sometimes I would call that a stupid simple use case. That's a stupid simple use case that will drive the adoption of the technology. At the same time, we have some really interesting use cases like the outdoor connectivity, which we've seen recently with the mass vaccination sites, and a few months before that, the mass testing sites as well, and providing ad hoc connectivity to connect a bunch of devices in an area. Logistics may look like a little bit of a juxtaposition for this slide, but the reality is we are working with hospitals for using robotics, AMRs, as we're calling them these days, to deliver supplies like prescriptions, materials, etc., as well as then moving to the left with indoor connectivity. This could be everything from basic connectivity to actually connecting things like crash carts and understanding where they're located and what's utilization rate that's happening. And then last but not least, shifting all the way to the right with the 5G ambulance. This is things like remote diagnostics or diagnosis with the patients coming in, being able to transfer charts. We actually had a use case. We were talking with a hospital in the Southeast. They wanted to connect their helicopters. So when their helicopters were coming in and landing on the helipad, they're able to quickly transmit that data. So that would even go beyond that. And of course, when you're talking about 5G and you're talking about an ambulance or a helicopter, you're getting off the campus. And when you get off the campus, then it's important to have relationships with the folks like AT&T, Verizon, T-Mobile, who we work with every day, to make for sure your macro connectivity and your network slicing matches your local connectivity as well. All right, next slide. All right, so network architecture, and I try not to make this too deep because I wanted to keep it high level for the audience, and of course we can go more deeply in this. We also have chosen to put an edge cloud, and by edge cloud, that's running the LTE core, but it's also providing compute capacity as well as the ability to integrate a healthcare organization's applications into our edge cloud, should that be something that they want to do. Of course, we support public cloud and private cloud, bring your own hardware as well, but our typical implementation is using an edge cloud on-prem. And then we have different flavors of radios, almost all of them available in 5G today. So we are deploying 5G as of July from a standalone deployment, as well as global variants for the different bands. But we have, indoor small cell Picos that cover, a few hundred square meters, all the way up to macro sites, which you see alongside the highway with AT&T and Verizon that cover tens of miles and thousands of subscribers. So we have the entire portfolio coming from our mobile networks business, and that all plugs into our enterprise solution. And then on the right, you see two different, crude kind of cloud structures over there. The first one is this regional digital automation cloud. That's actually Nokia provided. That typically resides in our data centers, and what that provides is a single pane of glass. So if you're administering maybe multiple campuses, you may have multiple private wireless networks deployed. This will give you the ability to log in and see the health of those networks, manage subscribers, all that from a single pane of glass. But at the same time, all the user data would stay local on-prem. So this is purely from a management point of view. And then I just wanted to as well show how it would integrate into the existing infrastructure that you would have at the campus, and the applications that could be delivered either as an application on top of our cloud or connected into your own infrastructure on campus. All right, that's the last one I think from my side on that.
Yeah, actually, the next slide, Matt. We'll switch gears here. We've got a few questions, but I do want to finish up this section. Then I think we'll go back to Oza. I think the questions we can take at the end. One question I had for you, Dustin, and you put a slide together for me on this: who buys? Who's the buyer within the hospital? And also, there's actually a question on this as well, which flips it around: is who does the hospital go to? And maybe Dustin, you can comment on this, then Oza. But somebody said, and obviously they're talking about the UK here, does a hospital go talk to the NHS, National Health Service? If it's a hospital chain here, do they go talk to AT&T, Verizon? Do they go talk to their systems integrator? How are they getting to you to have these discussions? So Dustin.
Yeah, thanks, Ian. And sometimes I do take you too literally, so that literally was your question, and I built a slide for it. So first of all, who buys? Really, it's the CIO office that we see are the ultimate decision makers. We at Nokia do actually have a substantial amount of business in healthcare. One of our marquee customers in the industry is UPMC, who's a longtime partner of ours, and I think are quite highly respected in the industry for being innovative and maybe forward-leaning on technology. So we do have a bit of knowledge there. Interestingly enough, we also a member of HIMSS, and we went into HIMSS and said, hey, who's making these type of purchasing decisions? And they said there's a lot of people. On average, they have seen 9 either influencers or decision makers in the organization on the healthcare side of the table, making those type of decisions. But ultimately, it does come back what we've seen to the CIO office. And then flipping that question around, I'm glad you did that, Aiden. That's good. I think it's kind of all the above. The UK may be a different bird because, and perhaps Canada's in the same boat, just because of the way the healthcare is funded. But however, here in the United States, we're seeing kind of all the above. All these organizations are going to have a relationship with their carrier, so they're going to call Verizon and AT&T, and some of them feel very comfortable with that relationship, and they look for them to implement that. And they do that today for things like DAS systems, for bringing the macro network indoors and providing connectivity, for patients and for the staff as well. So that absolutely happens today, and it's probably the de facto standard of how cellular is being implemented today in that setting. But as we move into private, that's going to shift a little bit. I mentioned earlier we have an agreement with Verizon and AT&T, so we would also like to continue to do the same thing. And instead of delivering DAS systems together with our carrier partners, we would be delivering private wireless, LT or 5G solutions together with them. They could also try to do it alone, or of course there are other vendors that offer turnkey solutions like Celona has, and so I think all those options are on the table for these organizations. I think the challenge is going to be maybe trying to filter through that and see what's most relevant and what's the path of least resistance with the least risk.
Okay, great. So Oza, back to you. So you've got the next couple of slides talking about use cases, and maybe you could touch on this point as well about how you've, how you connected to the, pardon the pun, how you connected to the hospital through partners directly. How it came to be.
Yeah, absolutely. I think we provided a pretty good overview of the ecosystem, right? Different technology options, different how to deploy it, and everything else. But I think hospitals, healthcare systems, they have to be really practical in getting started with their private 5G journey. That's what we're seeing as a reaction to. I think somebody will yell, that's preposterous if I say, hey, let's just replace all your Wi-Fi network with 5G and let's just move all your devices to 5G and all your applications should run on this because it's the best thing since sliced bread. We're not saying that. We're really guiding our customers to say, look, yes, the world could be a much better place when you have a fully fledged private 5G system and you're selecting devices accordingly and you have budget sources for both. But today we're in the early stages of the market, right? People are not waking up on a Monday morning thinking, yeah, I got to spend $1,000 on CBRS and I have to spend another $50 on Wi-Fi. They're still trying to see how they can plan their budget around IT, OT, and innovation teams, as I mentioned. So in priority order, here are the things that we've seen where customers are looking at in healthcare environments, partnering, creating a partnership between their IT, OT teams and their innovation teams. One is voice. Everybody's roaming around. They're always in stress. These communications need to be private and secure as well. So the ability to offer a clean spectrum, highly device-based security encryption with SIM cards, it's very attractive to a hospital who's buying hundreds of iPhones trying to run a voice over IP application. Once that system is in there, maybe it just covers one portion of the hospital, and this is where the clinical staff members usually are, and that's where those iPhones are, and that's the only location we want them to be. And after that, maybe it extends to some outdoor coverage. Maybe it extends to patient room technology, maybe those robotics that Dustin mentioned. And maybe we're simply doing this from a cybersecurity perspective, which, again, which healthcare organization is not under stress because of cybersecurity problems, right? So they might just simply look at this as, let's keep non-critical systems that are part of our facility away. Let's segment them out. And in the next slide, I give you one of our customer examples. They had a very practical system. I'm not at liberty to share their name, unfortunately, but they're a hospital system in the US Western region. They have a great relationship with Apple. They buy Apple iPhones for their clinical staff every year so often. And they have a dedicated voice application, collaboration application that they also use for data entry, barcode scanning, and things like that. And of course, that voice quality running on that device needs to be top notch. The voice service is actually local to the hospital. It doesn't talk to a cloud server or anything. It's just a local voice application. And they wanted to kind of move those devices away from the possible interference when they were running on Wi-Fi, right? More devices on Wi-Fi, as Dustin mentioned, increased latency, so they want to avoid that. So they moved over to CBRS with Celona. They're trying to take advantage of microslicing to maintain a guaranteed bitrate / latency. And you know, obviously, given the great coverage patterns for LTE, you know, we're averaging around 10 to 20,000 square feet indoors and 500,000 to 1 million square feet outdoor for the single AP. So that was also attractive, right? So they're not buying large number of radios to enable this coverage either. So early stages of the project, but again, our recommendation to any enterprise and specifically healthcare organization is to find one silver bullet, a critical application that has to work, and let's get the journey started. And then eventually you will reach an operational DNA to say, okay, let's expand to multiple applications. Let's actually create a budget item in our annual planning for this, and then the sky's the limit from there. So that's my take on the question.
Okay, so and you did a really good job because you actually addressed one of the other questions we had come in about, you know, what's the decision-making process, what gets started. So what you're saying here is there's a basic, I mean, what you were talking about there is a basic connectivity need, right, throughout the building. It was nothing more than I need to be able to hear you clearly all the time. And then once that's solved, then as you said, it becomes expanded out into different applications once the network is there, right? So good job. Well done, Oza. Okay, Dustin, back to you. This is the last slide. So lessons learned. What advice here? And I think you're going to build on what Oza just said, actually.
Yeah, actually, I could come straight off the coattails of that, particularly with looking at voice. Many of the devices today do support CBRS or Band 48 natively. Apple devices, I think, since Apple 10. With a few exceptions, and then the Galaxy, the Pixel. So there are a lot of consumer devices today you could slap a SIM into, or even an eSIM into, and connect it to both a public network and a private network, even simultaneously with dual SIM, dual connect. functionality, particularly in the latest iPhones, is pretty sexy. But when you look at the voice over IP applications, many of us use voice over IP today at home. The carriers do like to utilize that to get us off their public networks and free up some of that public spectrum. And I think many of us have probably used voice over IP on our AT&T or Verizon or T-Mobile phones, and maybe had some challenges with that, depending on how good our Wi-Fi network is when we go from downstairs to upstairs, or went out into the garage or something like that. So just really amplifying what I was just said. Having that ubiquitous connectivity layer that not only provides coverage but also provides mobility, because there's a reason Wi-Fi wasn't installed along the highways and LTE or 2G, 3G, 4G was installed. It's baked in. So it is truly better, fundamentally better for some of the applications. And bringing that into my slide, have a plan. Some applications like voice over IP really do need those attributes. You could have security sensitive applications that maybe healthcare records information or something like that would be transmitted. So every application is going to have unique attributes of the network. And so I always say, we need to segregate out these applications. So we have AT&T or Verizon on one end with the public network. We have Wi-Fi and Ethernet on the other end. But now we have a new tool in the toolbox that's actually really good news, because what you can do is you can pick the applications that need the attributes that tool provides of private LTE or 5G, put them on that layer, and it's actually going to free up the amount of demand you're putting on your Wi-Fi layer. And you're actually going to improve performance on your Wi-Fi layer by implementing private LTE or 5G. And we've seen that in practice a few times. In fact, been lucky enough to even bake that into use cases, or not use cases, business cases rather, when they were looking at doing some augmentation to their Wi-Fi network to improve the performance. And we were able to say, hey, if you put a private LTE network out there and move these applications over, you might be able to mitigate that investment into the Wi-Fi for net neutral. The next one is kind of coming into the business case, talking about understanding cost benefit analysis. And sometimes that's not clear. Ozer said early in the webinar that there's price parity with Wi-Fi. We absolutely see that. If you have a Wi-Fi 6 network already deployed, that's going to be a hard sell. You've already got a lot of recent sunk investment into that. But if you have a legacy non-6 network, or even going back to 2.4, or if you're looking at a greenfield deployment, there's actually a lot of price parity on there. So if you're looking at doing the LTE or 5G deployment to support specific use cases, you might be able to mitigate the Wi-Fi deployment. If you already have Wi-Fi, it goes back to my point number one. We can segregate out the use cases. Another thing that I really didn't have a grasp of when I started my journey about 5 years ago on this, structured cable, how much structured cable cost, and particularly in unique environments. And we see that like food production facilities, but we also see it in healthcare. Being able to pull a cable through an operating room is not exactly something that's not going to be disruptive. So there's a lot of disruption, there's a lot of cost associated with structured cable. And when you add that into the cost benefit analysis, private LTE starts becoming much more attractive. And the last one here is not really lessons learned. So I threw and advice up there. One of the things in healthcare that we've seen really have a sharp return on investment is asset tracking. And I know that there's asset tracking based on Wi-Fi, and it's hit or miss. I've heard the stories on that, or where it's at, but you don't really know which floor it's at, or maybe it's hitting the wrong access point. We at Nokia, we have a high accuracy indoor positioning solution that actually goes on top of our private wireless solutions, integrates into it. And so you can get resolution down, we're talking centimeter, I think it's 30 centimeters right now, resolution on where equipment's at. And it's easy to understand, hey, if you know where your equipment's at and it's being utilized more heavily, then you can reduce your capital investments into that type of intensive equipment. So maybe slightly tangential there, but a little bit of advice from all the conversations we've had in healthcare.
Actually, you say it's tangential, can't say it. But actually, we had a question about that. Is can you put positioning on top? The question was actually about accuracy of positioning for surgery environment, essential asset tracking. Obviously, within the hospital, there's a lot of very valuable, sensitive equipment, right? So you answered it, Dustin. Good job. All right, so Matt, if you have the next slide, before we sum up, I'm going to get through a few of the questions here. We've had quite a few actually. So the first one I want to touch on is spectrum. Both of you mentioned CBRS band 48. The question actually was regards to frequencies, both licensed and unlicensed, outside of the US. What have you seen being used? So if you're in Europe, for example, you have to go to the carrier. I think Germany's got some 3.7, I believe. Ozo, do you want to take that one first? What are the options out there for doing private networks internationally with no CBRS?
Sure, absolutely. Today, I think a good momentum in UK, Germany, I would say. Japan is also investing. I think US led the way with a system, a very big chunk of spectrum. 250 megahertz is a lot in the LTE 5G world. And the rest of the countries, even if they don't have that big chunk of spectrum today, they're trying to implement something similar. I think the ultimate goal for all countries is, can I give a clean interference-free spectrum to a dedicated enterprise location? US does it centrally coordinated through FCC certified systems called Spectrum Access Systems, also known as SAS. And UK has a different method of acquiring that spectrum and deploying it. Germany will have a different one. So it's up to infrastructure providers like us to say, okay, I have a single set of radio product portfolio. Depending on which country SKU you purchase, where you deploy it, we will adapt to that country's regulatory motion in registering that AP. So not everything is going to look and feel like CBRS internationally, but we see a pretty good pattern. There are leading countries, I would say UK and Germany, as we see it. It's not global right now. We're not going to see private LTE 5G across all countries today, but it's becoming, it's pretty common thing across countries as we speak.
Okay, and Dustin, kind of following on that a little bit, there's a question here. You showed your nano cells, which I think was CBRS in your diagram. So the question is, do they support other bands as well, 5 gig, et cetera, et cetera?
Yeah, so maybe tying that into the previous question as well. I might be in a kind of an advantageous position here with Nokia. Our carriers deliver services to 6 billion subscribers globally, and so we have radio products to support every one of those deployments globally. You know, both still have 3G. Believe it or not, we still have some 2G networks out there in some places like, you know, sub-Saharan Africa, 3G, 4G, and 5G. So we're at the cutting edge of the radio technology for sure. And you know, I think you hit it pretty well. You know, Germany with the 3.7 to 3.8, I think it's new band 78 is what it's called, is available for leasing. There's leasing agreements available in France. We actually have some 5G deployments we're doing right now in the UK. We had some really good references like Nippon Steel tied together with Toyota coming out of Japan. So it is a convoluted landscape when you look at global private spectrum. I've got a deck, and I think there's a monthly update our spectrum team does. It's you know, it's 20 slides long, and you know, here's what's existing today, here's what's coming down the pike. So you know, taking that back to our portfolio here in North America, which I did present earlier. Yes, that is focused on CBRS, and so a radio is going to be, you know, focused on a certain band of spectrum. We do have other radios, of course, here, in all the radios that are deployed with people like Verizon and T-Mobile and AT&T. We use the same radio portfolio for our carrier business as we do our enterprise business. So any of the radios that we have in our portfolio, we can use privately. And one step further on spectrum, we also have the ability to deploy, it's called Band 53. It's a global star band. We have both the radio, the CPE, and the agreement to use the exclusive license here in North America should CBRS not be available. You know, if you're in a coastal region, or if you're concerned about availability or being moved by the SAS, if you have truly a mission critical application, we can segregate the network even further and put it on that layer.
Okay, all right, so I've got one last question, and it may be a yes or no, but I started out saying we weren't going to talk about robotic surgery, and we had a question about robotic surgery, so I have to finish with that one, and then I'll do the quick summary, and then we can log off. So the question is, have you developed and sold any use cases for remote robotic surgery? I know it gets discussed a lot. Are we seeing it, or is it still in the theoretical hype phase? Oza, have you seen that one yet?
No, not yet. Certainly, that's going to require a lot of low latency real-time communication. So a local network, a locally hosted network is probably going to be required just for that last mile connectivity. But no, we haven't seen it yet.
Okay. And Dustin, you have your picture with your 5G with the latency chart and all those things. You're talking about low latency there. So have you seen those yet?
Yeah, so the answer was correct already. You know, the 5G, first of all, people think of moving from 3G to 4G to 5G as being a binary operation. It's not. It's very much an analog operation. And so as we move to 5G, yes, we have 5G today. 5G continues to improve. Some of those improvements are tied to, of course, 3GPP standards, and some of the requirements like ultra reliability and low latency, those are going to enable use cases like robotic surgery or remote surgery. Those are absolutely on the bleeding edge. You know, I don't think anyone's been under the knife yet with that. I'm sure somewhere in New Jersey in Bell Labs there's a lab somewhere that's doing some experiments, but probably not on people.
Yeah. Well, nobody that survived has been under the knife yet. Right?
Yeah.
And I did like your little pun there on the bleeding edge. I don't know if that was intentional or not. All right, so very quickly wrap up here. Obviously, everything we talked about today, we will send out slides. We will send out details on the recording. We've got a few more questions left, which I will get to after the session. But obviously, this is a growing opportunity. We've had a lot of discussion here. We talked about the inpatients, the outpatient. We talked about the applications. As Oza touched on very well, the demand for connectivity here is real. It could be as simple as reliable voice coverage throughout a building. You know, and then Dustin talked about on that chart here on the right-hand side, he had the ambulances there. You know, this is as much about connecting an ambulance for critical care as it is connecting a nurse in a ward. I mentioned telehealth because I like it, but this is all sort of part of the same pie. So those use cases do come up, as well as point of sale is something we didn't mention too much today, but there's a gift shop, there's a cafeteria, there's credit card processing, security, obviously. So really, you know, all of the applications you see in a metro market, you also must start to see in a hospital. CBRS we talked a lot about, of course, other bands as well internationally. And these apps can be complex. There's a lot of moving parts. I think, Dustin, you touched on this, that there's a lot of complexity there. There's a lot of specialized areas. But again, that connectivity, having that reliable connectivity, as Oza talked about, is very important. So with that, I want to thank you guys. Dustin sitting in his Nokia studio. Oza, I think you're sitting in a Tesla, if I'm not mistaken.
That would be correct, yes.
Okay, yeah. You see, he lives in California. Everybody drives a Tesla.
I'll give you one when you arrive.
And Matt, thanks for driving the slides today in case my power went out, which it didn't. We survived. So next webinar is in a couple of weeks, and we're going to be talking about agriculture next. So you'll receive details on that. Thanks very much.
Yep, thank you.
Thanks, everyone.